Hi there, this is Max, and we're going to get into the first technique of the course. In the first two modules, we really just set up everything for the rest of the course. By talking about how the allocator works and the vulnerability classes, the idea is that now we know how the allocator works, we can actually start using the allocator against itself and start to hit it where it doesn't expect. So the first technique is called FD poisoning. And it gives you a write, what, where primitive when done correctly, meaning that you can get the allocator to give you an arbitrary chunk to get back, which is really awesome. It's an extremely powerful primitive. So let's get started on that. First, it's a bread and butter technique. This is one of the first techniques that I think is worth learning. It's really powerful, and it's fairly obvious once you understand how the allocator works. The idea is we're going to corrupt the item of a singly linked list to have it point somewhere else. And now that we have it pointing somewhere else, we can have a chunk there. Because we can have a chunk in an unexpected location, we can cause all sorts of havoc. When I say fake chunk in that context, by the way, what I actually mean is we can put something in the allocator that is unintended and was not actually given out by malloc. So, for a quick review, we're going to talk about this with Tcache first, but this does also work with fastbins, but it's just a little bit more complicated. So with Tcache, remember it's a singly linked list. There are set a limit of 7 chunks per bin, and it is last in, first out. There's also a counter for each bin. The sizes range from hex 20 to hex 410 in size. Now, for some reason, they decided to overload the data structure, and the one we really care about in this context is next. But now you guys know what double free is, we can actually talk about this. So if I remove my camera for a second, we can see this key that's right here. And this key is what's used for double free protection. If you try to free the same Tcache chunk more than once, then it will have a value set here. When it sees that value that's set there, it goes, oh, I've already seen this before, so I think this is a double free. And when it gets allocated, it clears that key in order to not deal with uninitialized memory bugs. Cool. Next slide. So this is where I think the course gets really fun. We used to start to ask our questions of, what if we do this? What if we do that? What if we try to break this thing this way? And this becomes really fun. The Tcache is set up in a way where we have these linked list items. That's all we got. It's not that bad. And it's a singly linked list. And it turns out in the Tcache in particular, there's almost no verification on them. So what if we had some section of memory over here and we just changed this pointer to, instead of going to there, we had a point to something else we wanted. Well, now when the Tcache tries to take the chunk out of it and for an allocation, it will actually grab our pointer, our malicious pointer. And this could be over a function pointer or some other really valuable thing that we would want. And the coolest part is that, remember, this thick line is what the user actually gets back. And so if you have a use after free, or you have a buffer overflow coming from behind it, you can overwrite this FD pointer and point it to an arbitrary location, and it will return it back for you. So that's the general gist of it. We're going to corrupt the singly linked list pointer of a Tcache FD pointer. And now I'm going to explain graphically and step-by-step how this works. So here we have a Tcache bin with some size, and we have 3 different chunks. At this point, we are going to corrupt this arrow here. In the previous thing, I updated this, but it's actually not possible to update this in most cases. You're going to want to update a chunks FD pointer, not the bin itself. So now we have the ability to update this with a use after free or something like that, particularly that, the FD. we can then specify that to be at an arbitrary location, which is awesome. This is where the whole fake chunk concept comes in. Now, we actually don't have this allocated yet. We still need to get malloc to return this chunk to us. So, at first, we're gonna do some allocations. And you're probably thinking to yourself, Max, is it really that simple? I'm like, yeah, it actually is. Prior to 2.32, which added pointer mangling, which we'll talk about in a future video, there were zero protections put in place at all onto the singly linked list items of Tcache bin chunks. So you can simply corrupt the FD and point it anywhere you want, which is awesome. So again, here's the full step of how this works. We've corrupted it, and now we need to allocate it once. So at this point, we've allocated that first chunk, but that first chunk's FD pointer is now going to be the front of the list. Because it's at the front of the list, we can cause all sorts of havoc. And the next allocation will actually see this get allocated. And now, if we have the ability to write to this chunk, we can write to this arbitrary location. So again, this gives us the amazing primitive of a write, what, where primitive. It's one of the most powerful things we could ever ask for. So in order to do this with the Tcache, you need good control over the FD pointer. And that's the case for both the fastbin and Tcache. This is going to require a known location to write to, and a lot of times you're going to need an info link. If Pi or ASLR is disabled, then you don't have to worry about that. Maybe there's some static spots in memory on an IoT device. I don't know. But you're going to need a known location to write to. And of course, you need calls to malloc that give the chunk to the user, because if you can't control the sizes in any capacity and get that chunk back, it's useless. Now the drawbacks of this is that in 2.32 this does become harder to do, but you just need more specific leaks and need to know where you're currently at in on the heap itself. And this does require some good control over allocation sizes and the amount of allocations. The typical setup for this is what I mentioned. This vulnerability requires some sort of ability to edit the FD pointer. Nice enough though, a UAF where you can write to the first byte is helpful for this, a double free, buffer overflow where you can write null bytes and you're coming from a chunk below it, all are nice. After that, you need to be able to overwrite the FD pointer of the Tcache chunk with something useful. Finally, you need to allocate chunks until that fake chunk is allocated. And an extra complication to this is the Tcache does keep track of how many chunks are actually in the Tcache. So if I have one free chunk in the bin and I overwrite that FD pointer, because there's only one chunk in the bin, I actually can't get that chunk out because it will see that there's 0 chunks in the bin and not allocated. So there's a little bit of shenanigans and chunk tracking for a particular bin you need to keep track of, but at the end of the day, it's not that bad. So that is the Tcache version of the FD poisoning technique. Hope that makes sense, and there's more content on fast bins and pointer mangling, and of course exercises to come. Thanks.